should be doing it. Let's double check. Yep. All right. So we do have audio this time. But you remember in the first class I said the video recording is kind of a favor. There's no guarantee that it is going to work every single time. There will be occasions where I forget, make a mistake, or technical difficulties.
You said something about like when you write code.
Yes.
Don't go over details.
Well, when you watch me do it, okay, do not focus and try to frantically write down the details. Focus on the approach. How do I approach the problem? Okay. All right. So I'm saving the file, and I'm gonna download the makefile later too. So let me go to the makefile. Makefile is under News Forum. Okay. All right. Get to the. Let me get to the temp folder first. rxzvf complex.tar.gz. So now I have the folder created, and I will download my makefile next and copy it to this location. Just makefile, copy it to here. There we go. There's one more thing you have to change in the makefile, and that has to do with deleting. Also, when you clean it, you also have to clean the program gen itself.
I think you added in the last one.
We did? Okay, it's not here, so I'm adding this manually. .c. Okay, so now we got everything. All right. So do a make, and it's not automatically triggering gen just yet. That's because I don't have any assembly code to refer to complex.inc.
I found that one now.
Because otherwise, the lighting is washing out the screen. Okay. Well, that's because of the dependency. If nobody depends on it, it's not going to trigger.
It occurred to me at some point, but for a while I was just like, why isn't it working?
Ah.
Yes.
Okay.
Yeah. Oh, I have it dependencies everywhere, and it's not telling me.
Okay, so the first thing we need to do is to make that gen program, because otherwise I cannot write a single line of assembly code. So I'm just going to write gen.c, and that's going to pound include complex.h to get the structure definition, pound include stdio to include a printf, int main, struct complex c, printf. The way I like to do it is use the underscore. You can do it anything you can do it whichever way you want, as long as it is self-consistent. So this is just the size of a struct complex. The next one is to get the address of the two members. The first member, it doesn't really matter what the order is. I'm just going to take care of I first. So this is going to be c.i minus the address of, and then the address of C, and this is the last one, which is R, C.R minus the address of C. Okay, I need to change the table height because my wrist is not resting correctly. All right. Turn 0. That. All right. So I'm just going to make a complex.inc, and I want to trigger it. Oh, okay. Doesn't know how to do it. All right. Yep. I did not specify that. Put it over here, and gen is not specified anywhere either. So this makefile has not been updated yet.
did post one through the news, but it didn't have those type of modifications.
But this one does not even have gen as a variable.
But the
Maybe I didn't
which one
copy
you
it.
post last time, it has like everything.
I think I forgot to copy it. I downloaded it, but then I forgot to copy it over. So
Well, I
that's-
know it's the updated one that you posted online because it has the touch to complex.inc.
Everything.
This one does not have the gen, so let me look at this one. Okay, this one is saved as make one. Nope. This one does not have a gen. It's supposed to be the one in the news forum, right?
Yes.
Yeah.
That's supposed to be the updated
That's the
one.
one that you uploaded.
That should be this one.
And you did make modifications to that, but you did not include the variable gen
Oh, okay, I see.
or gen source.
Okay, so we just have to change that. Okay, there we go. And then we have to specify how to make those two particular items. That relies on gen source. Change the .o to .c to .o, and that will take care of that particular dependency. And then inc relies on gen, and the way to do that is to specify the executable, redirect to the include file. That should be it. No supposed to be target. Because inc is not defined. There we go. Yay. Alright, so we do have the definitions in complex.inc now, and I can now start to write code in assembly. Right, so let's go ahead and do it one at a time. Okay, this is the trick to reduce the complexity when you're writing programs. It's only to handle one subroutine at a time. Is there any particular request about the ordering of which one to implement first? Does anyone want to deal with ABC first? Because that kind of encompasses all of the dirty and difficult stuff that you have to deal with. Let's start with that one. Any objections? No objections? Okay, let's start with ABC then. Alright, so abc.c, and we'll look at abc.uppercase s. One is the, what is it missing? It's in complex.test. Okay, good. Alright. -o complex test.c and abc.uppercase s. There we go. Alright. Pound include complex.inc .text .global ABC and ABC. So pretty usual stuff, and entry code, exit code. I'll take care of those first because those need to be here regardless of what else I do here. That's the entry code. And that's the exit code. Alright. So what I have to specify in between now depends on, what is given to me as parameters and what I'm supposed to return. So now would be a good time to specify what is in the call frame. And I always start with OEBP. Some people may feel that, hey, we don't have to redefine this every single time because we know where it is. I just personally prefer to have the entire map of the call frame. These two are for certain, okay? Regardless of what is being done, every C subroutine will assume that these two items to be at these particular places. The next one in this case is the return value address, which is return address plus 4. This is the hidden parameter. And then we have the 3 actual parameters. The 3 actual parameters would be A, and that is after return value address. Return value address itself is only taking up 4 bytes, and that means the starting point of A as a parameter is return value address plus 4. B is after A, but the size of A is not 4 bytes, so you have to be careful and remember to use complex size for this one. C is the same way, but it is after B, so you have to add complex size to B because it is the size of B. Now C itself is also a complex, which means it's also of the size complex size, but with this one, it's not such a big deal, because nobody is after that, so I don't really need to do anything about this. There are 2 ways to approach the return value or the local variable. You can do it without the local variable at all. In other words, when we specify where complex add is going to store its value, we can just say, hey, put it where I'm supposed to return my own value, so I don't have to copy that one more time. Okay, so we can kind of use that as a shortcut in assembly language. Are there any questions about the code at this point? Okay. All right. So without any question about this code, the first thing we have to do is which operation. Can I do the add now? I cannot do the add now. I have to do the mode first, okay? But in order to use the return value of mode in add, I have to do certain things first. So I'm going to set up the call frame partially for add, and then I will call mode. Mode will give me the last thing I need for add, and then I will call add. Okay, so the first thing I have to push for add, which is something that I'm not quite ready to do just yet, but I can push one of the parameter on the stack, is to set up the space for C. So the way to do this, I'm just comment here and say allocate and push C. Okay, so this way I remind myself what I'm doing with the following code. Subtract long complex size from ESP. This will allocate that many bytes on the stack. Is that okay so far? So I'm allocating this many bytes for C, just so that I'll be ready to call complex add. I don't need to reserve the space to store the value of complex add because I'm going to do that trick and specify my own return value address to complex add so that I don't need to do the extra copying that is unnecessary. Alright, next thing we have to do is to this will only create the space or do the allocation on the stack, but the content of parameter C is not there yet. So to make the content over there, I have to use memcopy. Memcopy starts with the number of bytes to copy. Let's see. Let's double check. Okay, memcopy. Yep. Okay. So the last parameter is n, which is the number of bytes to copy, and that will be complex underscore size. And then we specify, and then we push the source, which is the address of the parameter itself. And then we have to specify the destination, which is the space that we just reserved earlier. So getting back to Vim. So we push the number of bytes to copy first, and then we have to push the address, not the content of parameter C. So to do that, we have to push, well, there are several ways to do it, but this is one way to do it. We push we push the frame pointer on the stack, and then we perform the actual arithmetic on the stack. So we have to add the displacement of parameter C from where EPP points to the item that we just pushed on the stack, which is the frame pointer itself. So this will handle the second parameter. The first parameter, yep.
Stack pointer or frame pointer?
It should be ESP, sorry. Yep, you're right. go. Because we just pushed that on the stack. And then the next thing we have to do is to push the first parameter, which is the address of the space that we just reserved. Okay. You can either do the pre-calculation before you push it, or you can push it first and then do the calculation after. The difference is if you do something like this, the calculation is off a little bit, because now you have to add 12 instead of 8 to the item that we just pushed on the stack. If you do the pre-calculation, then you push, then you only have to add 8, because we would not have these 4 bytes already reserved on the stack. Is that okay? I'm going to close the door because it's a little bit...
No, it would be 8. Because you took a snapshot of itself before actually increasing the stack.
When I push ESP, oh, it is still 8 away from...
So what do you mean by like a pre-calculation?
You do the you basically copy ESP to EAX, and then you do the calculation, and then you push it on the stack. But as Tristan said, actually this should be 8, because when I push ESP, it's using the value of ESP before the push operation, and therefore it is still only 8 bytes away from where it needs to point to. All right, so with all 3 parameters pushed, it is time to call memcopy. When it returns, it is important that we clean up the stack, because we don't want anything else on the stack when we set up the rest of the stack for calling molt. So in this case, we have to undo the 12 bytes that we have just pushed on the stack by adding 12 to the stack pointer. We do okay so far with allocate and push C. The next thing to do is to allocate the space for complex molt. Okay. Now this space is going to serve 2 purposes, because first of all, it's going to serve the purpose as the place to store the return value of complex molt, but then it will be used immediately as a parameter to complex add. So this space is going to be used for 2 purposes. So now we allocate space for, but it has 2 purposes: the return value of complex molt, which is also the first parameter to complex add. Is that okay? Any questions about the comment here? Okay. So to do the allocation, well, that's pretty easy. We just say subtract long the size of a complex from ESP, because we're just allocating it from the stack. Is that okay?
What's the return V?
Say again?
What's the return V? Return value?
Return value. Yep.
Can you just write return value?
Because I'm lazy.
There you go.
Fine.
Now it's not nice and
Exactly, it's not aligned anymore. Okay. So once we allocate that space, we can now push B, A, and then the address of the space that we just allocated, right? So to allocate the space of B, I can, well, I'm kind of lazy, so I just specify line 15 to line 23, copy to line 31, and we change all references of C to B. Go, and then we'll do it one more time for parameter A. Okay, so we say copy, oops, range first, 32 to 40, copy to 42, and change all references of B to A. There we go. All right. So by this time, what we have on the stack will be who's there?
George?
Because some people are outside.
Was I too loud?
Not yet.
he likes to go.
Okay, so we just pushed the space to store the result of complex mode. We pushed parameter B, we pushed parameter A, and now we have one last hidden parameter to push, which is the return, the address of the return value. Okay, all right. So let's go ahead and push it on the stack. Oh, but where is it? Well, what I'm going to do is I'm going to push ESP first and then do the calculation on the stack. So we know that it is somewhere above where ESP points to right now, and we just have to find out, okay, exactly how many bytes is it away? Well, it is 2 complex sizes away. And the easiest way to specify that is really just to say 2 times complex size. And those 2 complex size things, one is B and one is A. That's basically, where we put all the items. Are we doing okay so far with this? Let me just comment this line here and say push return value address on the stack, which is the hidden first parameter to call complex mode. Yep.
If I recall correctly, I tried doing a multiplication like that and it threw a fit.
It threw a fit. Well, I'm curious as to why it will throw a fit, and we'll go ahead and figure it out. So now we'll call complex mode, which will do the computation, and it will also store the structure to where the pointer points to, which is supposed to be 2 times complex sizes away from where the stack pointer points to. Are we still doing okay so far with this code? Sort of? Okay. After this, we have to clean up the stack. Okay, the 2 parameters need to be cleaned up. So we're going to add 2 times complex size to ESP, but this time without the parentheses because I am changing the stack pointer itself to adjust the stack pointer itself. But one more thing, I forgot one thing, because there's the hidden parameter which is taking up 4 bytes. Almost forgot that. All right. So at this point, the stack should be quote-unquote balanced, and the 2 parameters that complex add needs should be on the stack. But it's missing the first parameter, which is the hidden argument, okay, of the pointer. So now it is time to specify that pointer. And that pointer is actually easy to compute here because I'm doing the trick. I want complex add to store the result to where I'm supposed to store my result, so that I don't have to do one extra copy from local variable x. So that makes it extra easy because I just have to specify push long return value address EBP on the stack. And now it's time to call complex add. When complex add returns, ideally speaking, we should still clean up the stack before we return. So we'll go ahead and do the same thing as here because we still have the same kind of stuff on the stack. One will be parameter C, the other one is the result of complex mode, and then we have 4 more bytes for the pointer. So we have to clean up the stack, kind of like before. And that should conclude the subroutine. According to Tristan, this code is potentially problematic.
It could be that you're doing it differently than I did. It's possible I tried to do it as a base addressing.
Well, we'll take a look. We'll find out whether it works or not. And because this is the only subroutine defined in complex test, I can just take complex test away from the makefile and instead specify abc.uppercase s to make use of the assembly version of the same subroutine. Okay, so it's time to exit all, change the makefile accordingly to specify abc.uppercase s and take away complex test.c from here.
But we need
Don't you need the prototype?
so like a
Prototype?
prototype for that,
For what?
for first line of ABC dot or like test dot
Wow.
C.
It's in the header file.
Apparently not.
It's in the header file. Which is
Yes, it is in the header file, which is already included in main.c. Yep. someone is paying attention. It's already here.
It's just during class for several times it seemed like it was necessary to delete.
That's because I did not have an include file. That's because in class when I demonstrated using coord, there's no coord test.h or it's just not structured the same way as this one. But having extra prototypes does not help. Does not hurt. So it's okay if you want to do it that way. All right. So let's go ahead and give it a try. Okay. So we say make main.gdb, and for those of you who want to see that this can actually make clean and make again, let's see whether that works. No, it doesn't work. Let's see. It's complaining about assembler message.
9, 65. Don't have any.
G-stabs -c. Okay, first of all, double check this one.
Do we need include file?
It's not there.
Do we need library for that? Do we need library?
Nope, that's not what it's complaining about. Okay, did I miss anything here? Yep, I forgot to specify gen source .c equals .o. Make clean, there we go. It's important to remove gen as well because if gen is gone and you create an empty complex.inc, make will automatically assume that it is out of date and it will just redo everything automatically. If you do not remove gen, then it will say, hey, everything is still good, but guess what? I'm gonna touch complex.inc. I will first remove it and then touch it to recreate it, and that's why it's going to be empty. So that is the problem when you do not delete gen and the .o file first.
Well, I have it here on mine, and it's listed just as you have listed there.
And it's still causing problems?
After this, I would like you to take a look at it.
Okay, the computer does not like you.
Well, obviously.
Okay, let's double check and make sure. Okay, so we have. Oh, I don't have the include file removed. Okay, let me make sure that happens too.
I can see.
Because what is supposed to work is supposed to work.
You already have it there.
Yeah. It's because it's touched, right? Make clean will touch it, so it gets recreated as an empty file. So when I make again to make the main target, it should go through this whole process. It will first remake gen, and then it will use gen to recreate the include file. That is what it's supposed to do. All right. So now that we have a main, let's go ahead and say main.gdb to get into the debugger. I can just run this program, at full speed if I'm really confident that this is working. But since I'm not really that confident, I'm gonna set up breakpoints. Okay, so I'm gonna set up one breakpoint in complex mult and set up another one in complex add, because both of these subroutines will be called from ABC. So this is one good place to check to see if things are set up correctly or not. Okay, let's go ahead and run the program. 1, 2, 3, 4, 5, 6, and now we are in mult. Okay, complex mult. So the ordering is at least correct. I'm calling mult before add. And when we're here, we want to print A, print B. It seems correct to me because when we read, we are reading into R first and then I. But when we are listing I and then R. That's why they look kind of reversed. Are we still doing okay so far?
We have complex mode.
Say again?
We have the complex mode. We have to file. And then we are using C here. Is that right? Are we running C for example, the complex mode?
Yes.
What was
We
she
are
asking?
using
We use C.
those subroutines from our.
I'm still using
complex.c,
C subroutines for the other two.
Yeah,
The best way to debug a program of this kind is to only implement one assembly subroutine at a time. Because this way, there's no possibility that if anything goes wrong, it is ABC that is going wrong. So I don't have to suspect, okay, is it something in complex add, complex mode, or ABC, or combination? Now the combination thing, this is a side note here. The combination thing can be a real killer because there are occasions where one bug can mask another bug. Okay? Now, if one bug compounds onto the other bug and just make the program blow up in a more spectacular way, it's not a big deal. Not a big deal. It still blows up. Okay? But sometimes a bug can mask another bug, which means the symptom that would have been visible from one bug is no longer visible because of the other bug. Now that makes it a very nasty problem because the bug is still there, it's just not showing up in certain occasions. And that's why, I personally would only implement one subroutine in assembly at a time. Debug that whole subroutine, make sure everything is okay before moving on. Okay? Alright, so this subroutine is written in C. I have no interest in actually running this through, step by step. So I just press continue. The next breakpoint should be in complex add, which it is. And now I want to inspect, what is A and what is B. Oh, B is wrong. Okay, so now we have an issue. Somehow B is not being picked up correctly. And is A correct? Okay, let me think about it. Okay, so we have A, B, C, R, I. This is 1, 2, 3, 4, 5, 6. We first do the multiplication of B and C. So the product of A, B, and C, the real number. Okay, this is from both. Will be 15 minus 24, which is -9. So the real number part should be -9, and then the imaginary part should be 3 times 6 plus 5 times 4. So this is 18 plus 20, which is 38. So we should have a 38 here. And instead, what we're getting is the imaginary part is 1. No, excuse me, I take it back. I is -9 instead of R being -9. So everything is shifted a little bit, okay? Okay, so that means, I'm not passing the parameters correctly, okay? All right. If not, well, there are things that we can check that is actually useful here. One thing we can do is to look at the addresses of the parameters. In other words, we are checking what the C code or what the C compiler is expecting. Okay, so we're going to say what is the address of A, what is the address of B, the two parameters. All right, how many bytes are off from each other? They're 8 bytes apart, right? Because it takes 4 bytes to go from C to 0, and it takes 4 more bytes from 0 to 4. So they are 8 bytes apart, which seems to make sense, right? Okay, that seems to make sense. The other thing you can also do when you're debugging code like this is to look at the EBP and then dump, just the bytes, from that point on. Okay, so that's what we'll do next, is to do an X because we are examining the memory locations. So print is not really helpful for that one. You can do it, but it's not as handy as X for examine. We are going to examine a few items. From the frame pointer's perspective, we should have the ODBP, the return address, the return value pointer, and then the 2 parameters on the stack. So each of the parameter is taking up 8 bytes. So 8 times 2 is 16. 4 bytes for the return value address, 20. The return address for return, 24. And an OEBP, that makes 28. So if I dump 28 bytes, I should see everything. And 28 bytes would be 7 32-bit quantities. And I want to print everything in hexadecimal because it doesn't really tell me anything if I print it in decimal. So I want to print everything from EBP. So now I want to look at these things and say, okay, do they make any sense?
These two like bottlenecks.
Okay, well, we'll go through this and double check. The first entry seems to make sense. That looks like a legitimate EBP. this looks like a return address. So far, so good. This looks like the return value address of some kind. That's good too. These two correspond to the first parameter, and that is wrong already.
That one is wrong.
Huh?
That one is wrong.
No, these two.
Yeah.
This is -9, and that is 2. I should be having -9 and 38. Or the other way around. Okay.
Yeah, you should have hex 26 and 9, -9.
Yeah, this is -9. I know that for sure. Okay, but this is actually going into the imaginary part, so I know it is wrong already. But you can see everything seems to be shifted a little bit because this is actually the first parameter. This is actually our variable A from the top level perspective. Yep, go ahead.
That's a good question. So shifted which way, like? So shifted which way?
It's shifted what?
It's like which way, like too close to a EBP or opposite to EBP?
There should be another 4 bytes here. There should be another 4 bytes here representing 38. And then these two should be, over there a little bit. So I'm missing 4 bytes. Okay, I am missing 4 bytes, and let me think. No, I take it back. The representation of 38 in hexadecimal should be here. All right. Well, this is useful. Okay, this is really useful information. Even though the program is not working, I am gathering a lot of information using the debugger, which will in return help me understand what is going wrong with this program and eventually how to fix it. So I am missing 4 bytes, and so it's just a matter of figuring out why those 4 bytes disappeared, or how those 4 bytes disappeared. More likely than not, it has to do with cleaning up the stack. Okay, so when we clean up the stack, we clean up a little bit too much. Yep, go ahead.
How can we check it? What's the decimal value in that 00 waypoint?
Or instead of X, you can put a D. When you like a dump,
It was
after
split
W,
as
you can
decimal
put a D.
and show positive and negative.
Yep, D.
That's how we learn what to do when we use the X command. All right, so now that we know we are missing 4 bytes, on the stack, but everything else seems to be right? The fact that the pointer to the return address area is correct means the problem is happening before I push that. Okay, I lost 4 bytes before I pushed this. Yep, go ahead.
So how you know, like from here, our return address is right?
It just seems right to me.
Right to you, not to us.
It just seems right to me because it is I know it is before this point. The address is, let me see, it's 8F0 at this point. This is 930. So this is allocated before this subroutine. Okay. The frame pointer, remember this is old EBP, right?
Yes.
So this is actually allocated before the caller of this subroutine, which also makes sense. Because remember, I'm cheating and using the return value area that was passed to me. So it all seems to work out, from that perspective. So I'm just missing 4 bytes, somewhere, and the missing of those 4 bytes, or the destruction or the deallocation of those 4 bytes is definitely in my own code, because the return value address is pushed correctly. Okay, so now would be a good time to open up 2 tabs to look at both the source code and have GDB on the other side, because I cannot remember everything that I saw in GDB, so I might need to refer back to it. So I look at here, and I look at the only subroutine that I'm implementing in assembly, and this really helps to kind of rule out possibilities. Oh, is it this subroutine or is it the other subroutine? In fact, I know the problem is happening after molt and before add. Okay, so that means it's limiting the amount of potential error to let's see. Ooh. Okay. It's deallocating 12 bytes because it takes 12 bytes to call mem copy, so that is correct. It's not the problem. This one is the return value address to molt. We call, okay, complex mode does not have a problem because we saw that, okay, when we put a breakpoint in complex mode, it did display that the parameters are correct. So complex mode comes back, and this is where we clean up the stack and potentially clean up 4 bytes more than what we should. And I think I know why. This is kind of my fault. I forgot to mention that the subroutine will clean up the hidden pointer. A subroutine that returns an entire structure would actually clean up the hidden pointer, the hidden first pointer. It will clean it up, and that's why it is off by 4 bytes. That is why. So those 4 bytes are not supposed to be cleaned up like that.
So I have the same issue.
Yep.
I have it removing those 4 bytes and it's working properly. Everything's aligned.
Everything is aligned. Okay. Well, we'll see what happens with this one. Okay, and we'll.
So it removed.
I think that part is actually documented too. Sorry, go ahead.
So it removed the address every time, or just in this condition?
No, let's see here. I think it is documented too. It's just that I forgot to mention it. Let me see. There's cisp310.
But yeah, that was one of my things. I would remove the adding from +4 to the stack, and my alignment went away.
No, this okay. But it is actually in my own notes. So at one point of time, I actually know this. It is important to note that GCC assumes the callee, the subroutine being called, is the one to deallocate the pointer to the area reserved for the return value.
So that's under which section? That's under what section?
That is linked to in Moodle using this link here, cisp310 in assembly language programming. Okay.
Yeah.
Yep, go ahead.
We have this thing called how call and return are implemented. Return is implemented with adding 4 to the
Yeah.
second pointer.
Yep. So that basically means the same thing too. Yep. So it is referenced, it's just that when I was doing this in class, I forgot about this. Okay. Well, okay, let me check this out first and see if it's working now. Okay. So let's exit, do another make, main.gdb, so it will bring us into GDB automatically. Break at complex add, break at complex mode, run the program, 1, 2, 3, 4, 5, 6, print A, print B. This is mode, okay? We know that mode is working already, so this is not the issue. Continue, this is add, and this is where things did not work out too well. Print A, print B, it's all there. So when we add these, we should get 40 on one side and -8 on the other side.
Can you dump memory now?
Dump memory? Sure. So x/7wx $EBP, and it's all here. Yep.
So yeah, apparently when I did that, not adding 4 back to the stack after calling, it did resolve my issue, but after a few compilings, it crept up again. added it back, and it started working again.
Did you use return for, which is a return that automatically deallocates 4 bytes after the return?
No, just RET.
Just RET?
Yeah.
Your project has a lot of mysteries around it. But I am curious. I want to solve those mysteries.
I had the same issue before submit that program.
Okay. But now it does work. I just forgot that the callee is supposed to return to take care of those extra bytes. But it is documented both here in my own notes and also in the other one, which is the one in subroutines. And when you go to, sorry?
It's call and return.
Oh, call and return. Right here.
Yeah.
Which part of it?
That was how call and return implemented.
Just this one? No, that's not it. That is not it. But I think it's probably here as well. C calling convention, which is a document that is on Wikipedia. This is C deco. Okay, when return instruct class, the calling code allocates space and passes a pointer to this space via a hidden parameter on the stack. The called function writes the return value to this address, but it does not specify, who is responsible to clean up those 4 bytes. Whereas, in my own notes, I actually spelled it out. It's like the callee is responsible to clean up those 4 bytes. But I forgot to mention that in class. All right. Did you guys manage to finish the whole program too?
I had the same issue.
Mm-hmm. But did you figure out that there are 4 extra bytes, that got cleaned up, assuming everything is supposed to be cleaned up by the caller?
I submitted at like a 6.
Or did you actually do the right thing and read my notes and figure out, hey,
No.
there are supposed to be 4 bytes to be cleaned up by the
It
callee?
eventually went away magically. I have no idea, but I'm getting to proper values now. And I'm still deallocating 4 bytes for both colors.
So you're deallocating 20 bytes
Yes.
per call,
Yes.
and it's still working.
But then I removed those 4 bytes, but before it worked, then it giving me error. Then before submission, I removed those 4 bytes.
Okay. Okay, very
Giving me
curious.
an answer before submission.
Very curious.
See? Negative 8 and 40.
Huh?
Okay, and this is my code right here. See, I'm cleaning up heading 4, cleaning up heading 4. At one time, I changed this to do, and it sort of got better. I changed it to 0.
You know why? I know exactly why. It has to do with who is responsible for complex add. This is your own complex add. So when you play by your own rules, everything is good.
But I don't know how it just sort of corrected itself.
It did not correct itself. Okay, let me explain what might have happened. Okay. This is like one of those mystery shows, going back in time, in black and white, a grainy film, right? Okay, so what might have happened is the first time you did this, you were calling the subroutine in C. Now, when you call it in C, the callee is deallocating those 4 bytes. And by doing it this way in your own assembly code, you are going to, it's going to miss those 4 bytes and everything will be misaligned like what I did. Is that okay? And then later on, at some point, you wrote complex add or mode. It only has to be one of them that really matters. The other one is okay. So you wrote it in assembly, and when you wrote that subroutine in assembly, you did everything to make it consistent with the caller. In other words, you are both the caller and the callee. So you say, okay, the caller is going to deallocate everything, and then the callee doesn't have to do a single thing. So as long as the caller and the callee are consistent, the problem does not show up. Is that making any sense? And the problem came back because you might have suspected, okay, it might be my complex add or complex mode. Actually, complex mode is the problem. It might be my complex mode that is causing the issue. So at one point in time, you switch back to the C code, and then it's the callee, which is now in C, is deallocating those 4 bytes. So now you have to take. Do you see what I mean?
Yeah.
Did something like that happen, switching between C and assembly code for complex mode? Because it's complex mode that makes the difference. It's not complex add that makes the difference.
No, I stayed with my code until the problem went away. I stayed with the code that was having an issue until the problem went away in the abc.s. I did not switch code during that investigation and into why it was happening. But I do understand what you're saying.
Because if you if ABC is in C, and then complex add or complex mode is in assembly, then everything will still be off but it will be off the other way because the C code is assuming you are cleaning up 4 bytes that you did not. So there will be 4 extra bytes on the stack.
Yeah, it was my ABC subroutine and your C code, and I kept it that way until the problem went away. Then when the problem went away and it was consistent, then I reintroduced my files and it continued to run properly.
Okay.
Yeah. It is weird.
Okay. Alrighty. So that's it for the homework assignment. What about a new one? Are you guys kind of on track with the new one? Question about the new one? Yeah, go ahead.
The Gen C file for that.
Yeah.
It's kind of started. Are we finishing that, or was it totally done? Gen C files?
I do not remember what I have done. By the time I tar the whole thing up. So we'll take a look. We will take a look. Oh yeah, you have to finish it. It's just a non-null program, but it does not actually define anything.
Yes, it defines a new line.
So
Yeah, that's it.
Yep. So you have to do about the same thing as the ink file.
So I'm looking at that node H, so that's what we're going off of node.h.
Right. So you have to do the extra file include and stuff like that. In other words, look at the structure of the gen.c file of complex and mirror, the structure.
Yeah, right. That structure, I was a little confused with that structure.
It doesn't matter. I mean, you just print the members, right? Okay. So you can do basically the same thing. So you can say struct node C or N, printf dollar node underscore. I don't know which one is confusing to you. Where?
There's a member that's void star where.
Yeah, it's a void pointer.
Void one.
Yeah, it's a void pointer, which is just a pointer. So you just have to do it the same way as everything else, which is cast everything to a void pointer. Refer to the address of n dot where minus the base address of the structure itself. It's no different from what you do with complex. The type of the member has no bearing whatsoever in this particular code because we just need the offset to each individual member. So it might be a pointer to a function. It does not matter because we just need to know where to find the member given the address of the structure itself. So that's basically what you need to do, and you have to do it to the other members as well. Is that okay?
Struct node pointer, so that's pointer too. So they're all just going to be.
Well, any pointer is 4 bytes. Yep. You can have a void pointer, a pointer to an integer, a pointer to a structure, a pointer to another pointer, a pointer to a function. They are all 32-bit wide. Yep. Any other questions? It's still getting recorded, so if you ask questions now, we'll have it all recorded for eternity because it's YouTube. Nothing.
Well, nothing that needs to be recorded.
Nothing that needs to be recorded. Okay, very good. So I'm gonna stop the recorder because I think we got everything.